In today's lecture, I am going to discuss Poisson's ratio. Okay, before going to start Poisson's ratio, I would like to explain two terms. That is, the first one is longitudinal strain and the second one is lateral strain. Okay, to explain Poisson's ratio, I am going to take one example. Here, I have taken one object. It is having some initial length L. Then what I am going to do, I am going to apply a tensile stress or longitudinal stress. Okay, here I am going to apply tensile stress. Here you can see that there is increase in length of this object, and also there is decrease in its dimension. Actually, initially it is having some dimension, but when we apply tensile stress, this body undergoes deformation. That is, there is increase in its length and decrease in its diameter. Okay, here you can see when the object acted upon by a tensile stress, it is elongated along its length and contracted in its diameter. Okay, let us try to explain the same example diagrammatically. Here, this is the object and it is having some initial length L and diameter D. Then after applying tensile stress or longitudinal stress, this body undergoes deformation. That is, there is increase in length of object and also there is decrease in its dimension, that is diameter. Initially it is having diameter D, and finally when after applying this tensile stress, this body undergoes deformation. After deformation, it is having diameter D dash and length L dash. Here change in length, that is delta L is equals to final length minus initial length, and also change in dimension, that is delta D is equals to final dimension minus initial dimension. Here we can see that this delta L is positive, but the change in dimension is negative. So D dash minus D is equals to minus delta D, because change in dimension value is negative. Okay, here we define longitudinal strain, that the ratio of change in the length to the original length is called longitudinal strain. That is, change in length is nothing but delta L and original length is capital L. This is change in length, this is original length. And also similarly, lateral strain is defined as the ratio of change in the dimension to the initial dimension. That is, change in dimension is delta D and original dimension is capital T. This gives lateral strain. Okay, here to explain Poisson's ratio, what we have done, we have taken one example, that is, we have taken one object, then we have applied a tensile stress. Then after applying tensile stress, the body undergoes deformation. After deformation, we observe that there is increase in length of the object and decrease in dimension of the object. Okay, let us explain Poisson's ratio. Here Poisson's ratio is defined as the within elastic limit the ratio of lateral strain to the longitudinal strain is constant for a material of a body, and this constant is known as a Poisson's ratio. Okay, again I will take another example to explain Poisson's ratio. Here I am going to consider one object. Here we can see that this is the initial length and it is the breadth and this is the thickness of this object. Then after applying tensile stress, this body undergoes deformation, that is there is increasing length and decreasing breadth and also decreasing thickness. Here L dash minus L, that is final value minus initial value, final length minus initial length gives us delta L, and final breadth minus initial breadth gives us change in breadth, that is it is in negative sign because these two difference value is negative. So B dash minus B is equals to minus delta B, and also final thickness minus initial thickness is equals to minus delta T. And Poisson's ratio is denoted by sigma. Here Poisson's ratio is given by lateral strain by longitudinal strain. We know that lateral strain is given by, that is in general we are going to take this change in breadth, change in thickness by delta D, that is change in dimension, which is equals to final dimension minus initial dimension. So we can write here lateral strain is equals to change in dimension by original dimension by change in length to the original length. Here change in dimension by original dimension is denoted by beta, that is beta is equals to change in dimension by original dimension, and change in length by original length is denoted by alpha, that is alpha is equals to change in length by original length. So finally we can write that Poisson's ratio, that is sigma is equals to beta by alpha. This is the equation for Poisson's ratio, where beta is the lateral strain and alpha is the longitudinal strain. Okay, this is all about Poisson's ratio.